Hello everyone and welcome back. So we've added the collision geometry and it's going to work perfectly fine, and I wanted to add something more interesting to the sim. Now this setup here can work with can be used with in any scenario. We can use it in the volume, we can use it in the fire, and the idea here is to add some force that correlates to the surface flow and the surface orientation, um, and we're gonna use some of that to inject velocity into the sim. So, for example, I have these lines here, and my idea was that if a fire, for example, is coming along this crack, I would have something that if the fire touches this nearby rock, it's gonna advect it. It's gonna help it to move along the surface geometry, the surface flow, and wrap around it. When I have a piece of rock floating in the air and we have fire around it, fire underneath it, it's gonna wrap around it in an interesting way. And this force can be useful in many cases, and I think it can be really helpful with our fire to create, more connection between the rock's movement and the fire, because when we use collision only, it's not gonna add nice motion or inject anything from that surface, but with this technique we can inherit and pass along some of those details. So my idea was to analyze the surface flow, add some noise to it, and make sure that we can use this force to advect the sim along the surface. The other thing that we could do with this is with the smoke. When the smoke is nearby the surface, it's gonna move in an interesting way and also follow the curvature of the geometry, and this can be very interesting and it's very hard to achieve otherwise. So we have the SDF, which we eroded, and I'm gonna isolate the surface only, the surface field, and I'm going to reshape it and dilate because I don't want it to be I don't want the erosion to be too much. Okay, I want to add some padding back so that I have something that covers the rock and a bit more, not just exactly at the rock level. Okay, so the next thing is I convert this into a mesh. Okay, and I compute the gradient of this surface field. So here I use a VDB analysis, pardon me, and we compute the gradient of the field. And with this geometry, what I do is I scatter a lot of points and I give them an ID attribute. Okay, so I can track the points. And this is a custom advection that I did. So let's put down a VDB advect. And this point advect. Is it point advect? VDB advect points. Yes. So I'm gonna take these points and I'm gonna advect them. Let's say by the gradient force. See, they're moving. So the velocity is going to be the gradient, which represents how far along, or it represents the orientation of a volume. It's like a normal on a surface. And if we increase the the time, we can move these points very far. And the idea is we want to compute the cross product. Instead of using the gradient, we want to compute the cross product of this gradient and use it to advect the points. And let me do this. Let's try to illustrate these. So if we take these normals, these points, sorry, and let's compute the normals here. I'm gonna try and explain it. So this is the normal of the geometry. Okay, I'm gonna create a point VOP. And let's dive inside. I'm gonna compute the cross product of this normal and an up vector, and then plugged into the n. And you see we're getting these nice swirls that follows along the surface. If we normalize this and add it to the point position, we're gonna advect the points. And let's plug this back into P. And right now it's too much, so I'm gonna use a multiply node and use a 1/10, and I don't need to display. So if we move these points, you will see that they are following along. Okay, but I don't want to do it one time. I want to do it multiple times. So I'm gonna copy this, and then I'm gonna merge. So I have 3 substeps just to illustrate. I'm gonna merge this, this, and this. So we have a copy of the points copied 3 times. I'm gonna use an add node and use that ID attribute. Or what did we call it? Oh, it's not here yet, so let's create it, and there we go. We have a force or a curve that represents and follows along the curve, but it's not it follows along the surface, sorry, but it's not interesting. It doesn't have any interesting movements. So what I did is I need to create a custom advection system. My idea is to take these points, move them somewhere along data that we're going to sample from the gradient, and then we're going to use the cross product. So we're going to shift it to move along the flow. We move it a small amount and then ray it back onto the surface, make sure it's always on top of the surface, and then we merge it back, and then we do this operation multiple times. So if I run this, we'll see that we're taking those points and we're running them multiple times. Each time we sample a position, we sample a value from the gradient field, we compute the cross product of that, we add some noise to it, and then we move on to the next point. Once we combine all of these together and use an add node, we get this interesting motion. So let's take a look at this this point vault, what it does. So what I do here is I sample the gradient field from the second input. Okay, I normalize it and then I negate it to give me a vector that points outward, otherwise it's going to point in the inverse direction, and then I compute the cross product of this normal with an up vector, and then I do it one more time to get a vector that points in a different direction, and then I mix both of them, so it's moving along 2 different axes, okay, along the z-axis and along an x-axis, for example. And this is a multiplier to offset, and I add a noise to the point position. So instead of using the current point position, I simply add an offset to it, and that's what I keep adding to these positions. So we're advecting the points, okay, and then we're adding some offset, some noise to them. And with this ray, we make sure that it always snaps to the surface. So let's set this back to 1. And that's one sub-step. If we compare it here, we wouldn't see any difference. If we set it to 2, we will see 2 points. And if we keep increasing this, now we have 8 sub-steps. And this length really is just to have enough details. But if we go back here and, for example, change the noise size to 10. So let's try 1, 1, and 1. We're going to get bigger patterns. Okay, so that's the idea. And then we want to take these curves and convert them into a force, and that's pretty simple. We've done that many times. So I'm gonna resample them to have enough points. I'm gonna use a polyframe to represent that will capture the direction of the curve. So the force I want is going to be following along this. Okay, because I want to convert all of this into a velocity force, and I need to compute the tangent of this, and I'm currently storing it as n, and I also compute the length in case I wanted to use it as a multiplier. And then what else? And then I create few attributes. So I use the velocity, it's going to be the normalized n, which is the tangent, and then I multiply it by the color. So brighter means stronger value, and then as it gets towards the end of the curve, it goes to 0.1 because I'm adding this offset. The p scale is the same, so white is going to be thicker, black is going to be darker, and then the density is going to be similar as well. I'm using a point velocity to add some curl data, some curl noise, and then I'm transforming back all of this to match the scale of the scene, and then I'm rasterizing it. So that's my force, and this is my curl force. And right now we have two fields. We have a density field and a velocity field, and we're going to use a pump force. So I said density and V. So if we go to the fire temp and create a volume, pardon me, create a volume source, I'm going to set this to pump, and the first field is called density, the second one is vel. It's going to be injected into the velocity field. That's it. And then we paste in the path of this curl force, and make sure the enlarge field is on. And so far the force, it was very strong, so I pardon me, so I used the value of 0.01, and that was enough for this sim. I think the smoke one, I used a stronger value because I wanted to have stronger movement as the smoke collides and interact with the geometry, and it just helped, you know, create more interesting movement. That's it. But this workflow, this idea can be used in many different ways to, you know, create something that follows along the surface but still have, you know, nice motion, and that can be used in the sim as well. Okay, thank you guys for watching, and see you in the next video. Bye bye.